We are looking at enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. We just saw an extension of the swap middle algorithm where we take multiple chunks and move them around. Now the question is, how do I decode them? We'll look at it in this video. In fact, it's quite interesting. Basically, the idea is that I just have to, the movement is happening according to this key. I just have to sort of undo this. So at every point, I ask myself this question: where did this chunk come from, and hence where must it go back? For example, notice I get this message back, get this message from my side. Now I know the key was 201, which means that this message here has come from the first chunk on the original message, because the item number of 0, which is the first chunk here, is 1. Likewise, when I look at the second, say the first 0th first and second, so I look at the first chunk here, I know this must have come from chunk number 2 from earlier, because the item number of 1 in this key, or say the index of 1 in this key, is 2. Similarly, the third chunk, it must have come from 0 because the item number of 2 in this key is 0. Now think about this. This is extremely similar to all the other generalizations that we have done. Basically, we are trying to figure out where did this chunk come from, and hence all we need to do is to create a new key corresponding to this, which is basically given by the item number of all these elements, and move the messages around, and you will see that you are done, right? In fact, this is very nice generalization of the even or swap, as we saw. We can also take one more example. Let's say we are looking at 4 chunks. Now in here, the key is 1302. So when I look at this, I'll ask myself, where did this guy come from? And this must have come from 2, because the item number of 0 inside this key is 2, which means that this chunk has been moved over here. All I need to do is to move it back to 2, and so on and so forth. The point I'm making is that if I can create a new key from the given key, then I can decode this quite easily by just running the algorithm once again. And that's exactly what we will do. We will first determine the decoding key, and in fact, in other such cases, for example, in the generalized even or swap, in the generalized row column transposition, like in all of those cases, the decoding key is just given by e key, where the encryption key is say e key dot index 0 dot index 1 until dot index n chunks. Now once having done this, I just need to run the generalized swap once again by this revised key and the same number of chunks, because the number of chunks is not changing. The only thing that is changing is the revised key. So, and if I look at the code, it's going to look something like this. Here I'm just going to generate the new key, and of course I will move this according to the D key. This is pretty much the same algorithm actually. I'm just running it by the D key, right? So let's just do this ourselves in code so that we understand this better. Let's say we have, so I'll make my key, let's say 2103 or something. Say 2, I come back here, I say maybe 2031. So nothing stays at its own place, everything moves around. Now I come in here, I just define a new function. Let's just call it, let's say sweep mid general decode. So I come here, I say, okay, look, let me just, let's say, decode this, decode. Now clearly the inputs remain the same. I do the same padding if need to. I first create the decoding key. So I call it, let's say, D key. I create a list where D key is, let's say, 0 of, let's say, length n chunks, right? So I'll just, n chunks is the parameter I'm passing. So I'll just say n chunk, it is n chunks actually, right? So I pass this here, I create the D key. Now I must populate these values. Like I said, it's basically index of 0, index of 1, index of 2, and so on and so forth. So I say for kk in range, for example, n, chunks, kk in range n chunks, I will just do k, D key, say kk is equal to, basically D key kk is equal to key, which is my encryption key, dot index, say kk, right? Like this is just finding the index number. And having done this, all I need to do is to now run my algorithm not on the key, but in fact on D key. Everything else will remain the same, right? And think about this. This is quite beautiful. Now if I were to, let's say, I just copy this. So now having done this, I can test this code. I'm just going to take my, let's just call it X. So swap mid gen, say, decode. Now obviously I must call my correct function. So I just go and copy this whole thing over so that I call this right function. I must send the encoded input, which is X swap mid gen, and So n, say n chunk, which is say 4, and I will also send the same key, right? So if I do this, I expect this whole thing to work. Let's just see this working. So my X was, of course, meet me in the lobby. X swap, say swap mid gen was whatever it was. If I decode this now, if I look at the decoded, version of this, it is indeed meet me in the lobby, because all that has happened is that these chunks had been moved around and now they have been restored back. Now let's take one more example in the same message. Let's say I were to do n chunk of say 6 chunks this time round, and I must then include, let's say, 5, and maybe I'll put 415. Yeah, whatever this means, it's going to move my messages around. Now my key has to be between 0 to n chunks, all the numbers. And with this done, I expect again this thing to work. So let's say I do this now, xt. So let's say x swap mid gen is now something else. And now if I look at mid gen decode, it meets perfectly fine. It just decodes the whole thing. So this is how it's generalized. It's nicely decoded, quite logical. Think about this, quite interesting too. In general, if you find that this way of learning is fun, do look at our website, because there are many such activities. Take care. Thank you so much. Enjoy programming.